I'm going to show you a couple things in this video. The first one that I'm going to show you kind of, I didn't even think about it until I was watching an AVE video the other day, and he adjusted his variable drive on his lathe to cancel out chatter by varying the RPM of the drive with a switch that he put on it. And I didn't even think about it till then, and so I'm going to show you that what we used to do on the mill that's pretty similar to what he was doing, except we used to do it manually on the manual mill. And then I'm going to show you another thing on the horizontal mill about a tapping cycle and doing a manual rigid tapping cycle with the manual jog hand wheel. That's kind of unusual, and I'm not sure if you can do that on every control, but this Mitsubishi Meldis control over here on the horizontal mill does do this. Okay, I'm going to try to demonstrate something here that might be of some help. I've intentionally taken a 1/2 inch end mill in here and it stuck it out long. This is 2 inches long and the stock is about 2 inches thick. And I want to show how to get up inside a corner here and reduce your chatter to a minimum. This is going to chatter in the corner for sure, but there's methods you can use to try to keep this finish sort of decent in the corner. So I'm gonna intentionally move forward. This I'm not used to this machine. It has these safety handles on it that are kind of cumbersome. Okay, I'm gonna move over a couple of thousandths. We're gonna take another finish cut across here, and I'm gonna show you what we used to do on the Bridgeport mill a long time ago. It's been a long time since I run a manual machine, but we used to do this when we had long end mills into like 90-degree corners like this, and how we try to get the finishes as good as possible in these corners that are the same radius as the end mill. When you plunge into the corner, it's going to want to chatter, and I'll demonstrate it without doing anything first. We'll just mill up into that corner, and I'm just going to let it chatter, or just let it do what it normally would do if I just milled straight up in there. And you'll see when we start coming to the corner, you get in there, I'm going to go, see, that's a couple of thousandths beyond the wall, and then we're going to mill outward. Okay, that leaves a pretty good amount of, I don't know if you could see it on the video or not here in the camera, but you could hear it. It chattered pretty good in the corner there. So what we're going to do is we're going to come over here a little bit more, take a little bit more stock off. I'm going to do this in the climb milling direction. Spray a little WD-40 on there. And what we used to do is when you approach the corner, these safety handles are messing me up here. What we used to do is pulse the spindle on and off like this, and you can come right up into the corner. Let the spindle almost coast to a stop. While it's coasting to a stop, you can slowly feed it up in there a little bit further. Okay, got about 2 thousandths into this wall now. Now you got to get over here on the other handle and get ready to feed it the other direction. Turn the spindle on, pulse it on a couple times. Once you get away from the corner, you can cut. And you can do it without getting too much chatter. I'm going to blow this off. So I don't know if you can see how much cleaner the corner looks like that. You can do it like that. Let me come back up on here where I'm actually taking a little bit of a cut. We'll do this in I'm going to zero my x-axis there, clamp it, and we'll come up in here in the conventional direction. Put a little WD-40 on there. So as you approach the corner, the end mill's going to chatter if you don't do anything with this long of a cut length, this long of a tool, so you can start pulsing the spindle on and off. Here I'm coming into the corner now. I've gone about almost 4/1000ths into the other wall here. Spray some more stuff on here. And now you clamp your y-axis in this case, and then we're going to unclamp the X a little bit. We're gonna get ready and feed over away from the corner. I'm gonna blow this off here. I don't know if you can see how much better the corner looks there if you use this technique. This is one technique to use. The other technique would be to raise the spindle up, and you can plunge down if we get up above the corner here. Let's go about 5/1000ths. It's about 5/1000ths into the corner both directions in the X and Y. It's about that. I'm going to zero my X and Y here. Now what you can do, if you want to do this way, is you can actually pulse the spindle on and off here, because it's going to chatter. If I just plunge this straight in here, it's going to chatter in this corner. See, it's taking a little bit off of each side. But you can actually see how it's starting to chatter already. I'm coming down, and I'm turning the spindle on and off here. And you can do this to get the corner too, and then feed from either side up to this 0 point that you've established here. Here it wants to chatter, but when I turn the spindle off and it coasts down, it stops the chatter. Now that we've got all the way through, we can come back over here to the side. Let's come out the x-axis direction. Go down with the spindle all the way. You see how nice the finish looks in the corner here right now? See, this is a long cut length, and it would chatter. Well, you heard it when I did it with nothing. And so let's come down with the spindle here all the way. I'm going to mill this in the climbing direction. And when you come up close to your 0 point, on your digital readout, you can start almost there. You can let the spindle coast to a stop. Okay, that's my 0 point in the X. And then I'm going to get ready in the Y axis here to feed away from it. As I pulse the spindle on, the minute I get away from the corner, I can feed, and it's all right. This is a technique we used to use when we were making taking long cut lengths like a finish cut. After you roughed it all out and you wanted to finish it, but you didn't want a bunch of chatter in the corners here. Let me blow this off here again. So I don't know if you can see it, but the corner has a nice finish with very minimal chatter in it for this cutting with this whole long cut length of this tool here. This is what the technique we used to use. You either plunge straight down in the corner at your finished spot once you get it roughed in, and then mill up to it, but it's still going to chatter when you get it in the corner because you got like 90 degrees coverage on this end mill here, and they don't like that. They're going to chatter usually. And this is a carbide end mill also. This can be even worse with a high speed end mill, or a high helix end mill will even chatter more because it has more flutes in contact with the workpiece. But you can see how there's very minimal chatter there. So this is the technique we used to use mostly when we were milling NASA parts in aluminum. Back in the mid-70s, we used to do this on the Bridgeport mill. And back then we didn't really even use carbide end mills hardly. We used high-speed steel. Well, in aluminum you could use high speed, it wouldn't be a problem. So that's just a little method. I haven't done this in a long time. On the CNC machine, I'll generally plunge the corner straight down like I did this last time with this thing, and then I'll mill up to it. So I'll do a bunch of drilling cycles down here until I reach my center point of the corner with the radius of the end mill, and then I'll mill up to it if I'm milling around a pocket. It's generally the way I do it. And on the plunging tool, I usually grind away the flutes all except the very last maybe quarter of an inch of the flutes. I grind them away so it's not making a big contact, because that's what causes this chatter, is you're making a contact along the whole length of this tool, and it chatters that way. I'm going to go over to the horizontal mill here and demonstrate something that I kind of learned by accident, but it's kind of interesting, and it can help you do stuff manually on a CNC machine. I did this just by accident one day, and I learned that this machine will do it. I don't know if all machines will do this, but this Meldis control that's on this machine will do this. So what I'm going to do is I'm going to drill and tap some holes manually in the machine. So I'm not going to make any program. I'm going to do a little MDI command to get the tapping cycle started, but then I can manually jog this machine once it's in a tapping cycle and tap a hole with the hand wheel. So I'll demonstrate how that works here on the machine. So I got to prepare the part. I got this part in here. This one, the earlier part of the video, I was milling the corner on, and I'm going to drill a few holes down here with tools I already have in the machine, and then we're going to tap them manually and see how that works. Okay, the first thing I'm going to do is I jog the tool up here and just kind of eyeball the tip of it flush with the end of the part, you know, the face of the part or piece of stock. And then I'm going to zero out my display here on the Z. So I know how deep, because these holes, I drilled the holes an inch deep into here, and I don't want to drive the tap all the way in there and break it off. So, and you know, this is a blind hole. I'm even making it more difficult because it's a blind hole. And now I'm going to jog the tool back a certain distance, and I have to do a little MDI program in order to enable the tapping cycle. This tool was in this long extension for another part that was already in the tool changer, so I'm just using what was already there. So I'm going to jog the tool back in the Z. It's like my Z axis here, and I'm going to jog it back to 2 inches above the part there, so that we can enable this tapping cycle and not hit the part. We're going to go down a little bit with the tapping cycle in an MDI just to get it enabled, and then we can jog the machine. Okay, I'm going to go to my MDI screen, so here, and I'm going to, the way this machine works is it remembers the MDIs. You don't lose them like some machines. And I'm going to come all the way down to the bottom of the page here, and I'm going to enter in just a tapping cycle, but I'm not going to give it, I'm going to do it in the incremental mode. So I'm going to go G91 in the block, and then G84, and I'm gonna, well, first this machine, I should give it a spindle speed of some sort. So let's say we'll say 100. Just, it doesn't really matter, but it has to have a spindle speed for a tapping cycle. Then we got to go G84, and we're gonna go Z minus 1.1 inch out in. That's why I moved it up 2 inches. And then we got to, what's the pitch of a gotta get my calculator. The pitch of a half 13 tap. So it's going to be 1 divided by 13.0679. So we're going to put a feed. This machine, you put the feed on a tapping cycle as the actual pitch of the tap. Feed of 0.076923. End of block. And then we're going to go MOO to stop things right here. Okay? And we got to go back down to this cycle here on the G91 line. And we push input, and that enables the MDI setting complete. So when we push cycle start here, it's going to execute this little tapping cycle. It's going to go down and tap back. Well, it's just going to go in and out an inch deep. And because to turn the GoPro camera on here, we're 2 inches away here. It shouldn't hit anything. Although I'm going to turn the rapid movement down to 1% just to be safe. So we go into the MDI mode, and when I push cycle start, this should it should execute this tapping cycle. I think. Yeah. Okay, now it's tapping in. And the speed doesn't matter here. We just want to get the tapping cycle synchronized with the spindle. Because I haven't given it a G80 to cancel this tapping cycle, it will be enabled now, even if I put it in the jog mode on this control. I don't know if this will work on like a Haas or a Fanuc control or something this way. I've never tried it. Let me put this camera down, and I got to get jog handle and I'll show you. Now I have the machine in the jog mode, the handle jog. So if I move it, you see how it's jogging. I don't know if you can see this. If I can do it. See how it's jogging the and synchronizing the tap with the jog. See, so if I jog it down to the part, I can literally tap the hole manually here. Let me set this down for a second, get some tapping fluid of some sort, put in that hole. Put some tapping fluid in these holes here, so we have something on the tap. Keep bringing the camera up a little bit so I have more room here and I can show you the jog wheel at the same time. So let's see what happens here. See, coming down to the hole. Let me put my display first on the display so I can see where I am. I'm going to tap this hole. So, I'm jogging the hand wheel. Okay, I've reached almost to the part here. See, I can actually go in and back it up like that. If I want to clear off the thread for some reason, and I can go back in. See, I don't know if you can see it here. Let me point the camera down a little bit. You can see that I'm actually jogging the machine. I don't want to go too deep here. I went down 3/4 of an inch there. The tap. Let me blow that tap off here. Okay. Now I'm gonna move over to the next hole in the x-axis over here. Okay. I put the holes 1 inch apart. Then we go back to the Z here and jog down again. And see, I have control. I can jog it back and forth, and it's still synchronized. So you could even back it up, you know, like you were hand tapping it, and break the shaving. Okay, I'm gonna go 3/4 of an inch deep. That's right there. I mean, I drilled the holes 1 inch deep. I could probably go deeper than this, but I'm just going to be safe here when I do it. If I had a bottoming tap, I could probably drive them all the way to the bottom of the hole this way. I'm going to go over to the next hole, put them 1 inch apart. Okay, back to the Z. I'm going to put my jog rate at 1/1000th of an inch per click, and then go back in here. It's just like as if you were hand tapping the hole. See, if I put this up the fastest, see how fast it's synchronized still until I hit reset. So let me hit reset, and now when I jog it, it's no longer synchronized. I don't know if you can see how they look. They look pretty good. I'll get the gauge and check them with a thread gauge. So here's the thread gauge. half 13 thread gauge. Let's see how this goes as far as the thread goes. I don't know how good that tap is, but okay, so that's the go gauge. It actually goes in there quite snugly. So the thread's not oversized or anything. No go won't even start. So it does tap a good hole. It's not like it's, and you saw me back it forward and backwards in there. Must be some crud in that hole. So they gauged fine. I mean, that one's a little snug actually. But this tap's been used quite a bit in here. Might be a little worn. Been tapping 17.4 stainless with that thing. So that's how you manually tap a hole on a Mitsubishi Meldis control.